Hello students, myself Jyotirmoy Sahu. I am the lecturer of Electronics and Telecommunication Engineering. So in previous class we have already discussed about the pin diagram of 8085 microprocessor. So today we are going to discuss about the register organization of 8085 microprocessor. So there are two types of registers. One is general purpose register and second one is special purpose register. So first we will discuss about the general purpose register. The 8085 has 6 general purpose registers to store 8-bit data. These are identified as B, C, D, E, H and L. These can be combined as register pairs BC, DE and HL to perform some 16-bit operations. That means if these registers are used individually, then it works, means it perform the 8-bit operation, and if we are pairing these registers, then it can perform 16-bit operation. So these registers are used to store or copy the temporary data by using instructions during the execution of the program. Next is special purpose register. So accumulator and flag registers are under the special purpose register. So what is accumulator? The accumulator is an 8-bit register because it can store 8-bit data. That is the part of the arithmetic and logical unit, that is ALU. After performing the arithmetical and logical operations, the result is stored in accumulator. Accumulator is also defined as register A. Next is flag registers. The flag register is a special purpose register and it is completely different from the other registers in microprocessor. It consists of 8 bits and only 5 of them are useful. The other 3 are left vacant and are used in the future Intel versions. These 5 flags are set or reset. When the value of flag is 1, then it is set to be set, and when the value is 0, then it is set to be reset. After an operation according to the data condition of the result in the accumulator and other registers. So the 5 flag registers are sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. So first we will discuss about sign flag. It occupies the 7th bit of the flag register, which is also known as the most significant bit. It helps the programmer to know whether the number stored in the accumulator is positive or negative. If the sign flag is set, it means that the number stored in the accumulator is negative, and if it reset, then the number is positive. That means if the sign bit of a number is 1, then the number is negative, and if the sign bit of a number is 0, then the number is positive. Next is zero flag. It occupies the 6th bit of the flag register. It is set when the operation performed in the ALU, that is arithmetic logic unit, results in 0, that is all bits are 0. Otherwise, it is reset. It helps in determining if two numbers are equal or not. Next is auxiliary carry flag. It occupies the 4th bit of the flag register. In an arithmetic operation, when a carry flag is generated by the 3rd bit and passed on to the 4th bit, then auxiliary carry flag is set. If no flag is set, that is it is reset, this flag is used internally for BCD, that is binary coded decimal number operations. Then next come to parity flag. It occupies the 2nd bit of the flag register. This flag tests for the number of 1s in the accumulator. If the accumulator holds even number of 1, then this flag is set and it is set to even parity. On the other hand, if the number of 1s is odd, then it is reset. That is, it is set to be odd parity. So, if even number of 1s means 1 are present, then it is known as even parity, and if odd number of 1 are present, then we say that it is odd parity. Next, carry flag. What is carry flag? It occupies the 0th bit of the flag register. So, if the arithmetic operation results in a carry, that is, if result is more than 8 bit, then carry flag is set, otherwise it is reset. Next, distinguish between SPR and GPR, that is special purpose register and general purpose register. So first, what is special purpose register? Special purpose registers hold the program state. They usually include the program counter, stack pointer and status register. Three types of special purpose registers are the instruction register, instruction pointer, and program status bar, that is PSW. When the control unit fetches an instruction from memory, it stores it in the instruction register. Next, general purpose register or GPRS. General purpose registers can store both data and addresses. That is, they are combined data or address registers. There are 6 types of GPRS are there, namely B, C, D, E, H and L. The general purpose register can store a data or a memory location address, hence called the general purpose register. It is a multi-purpose register. They can be used either by a programmer or by user. Next is stack, stack pointer and stack top. So first, what is stack? The stack is a LIFO, that is last in first out data structure, implemented in the RAM area and is used to store the addresses and data when the microprocessor branches to a subroutine. So it is a stack. Then stack pointer. It is the 16-bit special purpose register used to store the address of the data which is recently entered into the stack. The data which is recently entered into the stack, the address of that data is indicated by the stack pointer. Then what is stack top? The last memory location occupied by the data in the stack is known as stack top. Next, interrupts of 8085 microprocessor. So first of all, what is interrupt? Interrupts are the signals generated by the external devices to request the microprocessor to perform a task. There are 5 interrupt signals, that is trap, RST 7.5, RST 6.5, RST 5.5 and INTR. So interrupts are classified into the following groups based on their parameter. So these are vector interrupt, non-vector interrupt, maskable interrupt, non-maskable interrupt, software interrupt and hardware interrupt. So what is vector interrupt? In this type of interrupt, the interrupt address is not known to the processor. So the interrupt address needs to be sent externally by the device to perform interrupts. For example, INTR. INTR is the non-vector interrupt. Next is maskable interrupt. So in this type of interrupt, we can disable the interrupt by writing some instructions into the program. For example, RST 7.5, RST 6.5, RST 5.5. Then non-maskable interrupt. In this type of interrupt, we cannot disable the interrupt by writing some instructions into the program. For example, trap. Then software interrupt. In this type of interrupt, the programmer has to add the instructions into the program to execute the interrupt. There are 8 software interrupts in 8085 microprocessor, that is RST0, RST1, RST2, RST3, RST4, RST5, RST6 and RST7. So these are the 8 software interrupts in 8085 microprocessor. Next is hardware interrupt. There are 5 interrupt pins in 8085 used as hardware interrupts, that is trap, RST 7.5, RST 6.5, RST 5.5 and INTA. So these are the various types of interrupts available in 8085 microprocessor. Next is masking of interrupts. Masking means disable of interrupts. So two pins are used to disable the interrupt. One is set interrupt mask SIM, and second one is read interrupt mask RIM. So what is SIM? It is used to implement the hardware interrupts, that is RST 7.5, RST 6.5, RST 5.5 by setting various bits to form the mask or generate the output data via the serial output data line, that is SOD. First, the required value is loaded in accumulator, then SIM will take the bit pattern from it. Next, what is RIM? That is read interrupt mask. This instruction is used to read the status of the hardware interrupt, that is RST 7.5, RST 6.5, RST 5.5 by loading into the A register, that is accumulator register, a byte which defines the condition of the mask bits for the interrupts. It also reads the condition of SID, that is serial input data bit, on the microprocessor. So this is all about the chapter 1 of microprocessor, that is 8085 microprocessor. So thank you.